Welcome to today's paper reading. Today's paper is titled, TripoSR, Fast 3D Object Reconstruction from a Single Image. This paper was published on the AR14 preprint by Dmitry Tochilkin and colleagues from Stability AI and TripoAI. The TripoSR model is introduced as a 3D reconstruction tool that utilizes a transformer architecture for rapid 3D generation. It can produce a 3D mesh from a single image in less than 0.5 seconds. The model builds on the LRM network architecture, incorporating significant improvements in data processing, model design, and training techniques. Evaluations on public datasets demonstrate that TripoSR outperforms other open-source alternatives both quantitatively and qualitatively. Released under the MIT license, TripoSR aims to provide researchers, developers, and creatives with the most recent advancements in 3D generative AI. Figure 1 showcases the TripoSR model, which excels in reconstructing high-quality 3D objects from single images at an impressive speed of under 0.5 seconds. This model not only achieves state-of-the-art performance but also demonstrates remarkable generalization capabilities across various object types and different domains. The figure highlights the model's efficiency and versatility in handling diverse input images, making it a significant advancement in the field of 3D reconstruction. The field of 3D generative AI has seen significant advancements, particularly in the convergence of 3D reconstruction techniques and the influence of large-scale datasets and improved model architectures. However, challenges remain, such as the scarcity of 3D training data, slow generation speeds due to extensive optimization, and difficulties in precisely controlling the output models. In contrast, the TripoSR model offers a solution by enabling fast feed-forward 3D generation from a single image in under 0.5 seconds on an A100 GPU. This model demonstrates superior performance and control, making it a valuable tool for researchers and developers in the field of 3D generative AI. The TripoSR model is designed for single-image 3D reconstruction using a transformer architecture. It consists of an image encoder, an image-to-triplane decoder, and a neural radiance field, NERF. The image encoder uses a pre-trained vision transformer model to project an RGB image into latent vectors, which are then transformed into a triplane RF representation by the decoder. This representation is optimized for complex shapes and textures. The model does not rely on explicit camera parameter conditioning, aiming for robustness in real-world scenarios. Data improvements include a carefully curated subset of the Objaverse dataset and diverse data rendering techniques to enhance generalization. Model and training improvements focus on optimizing triplane channels, incorporating a mask loss function to reduce artifacts, and using local rendering supervision to handle high-resolution rendering efficiently. Table 1 provides the detailed model configuration of TripoSR, highlighting key parameters such as image resolution, triplane channels, and learning rate. The image resolution is set at 512 by 512, ensuring high-quality input for the model. The triplane channels are configured at 40, balancing reconstruction quality and computational efficiency. The learning rate is set to 4e-4, which is crucial for the model's optimization during training. Table 2 presents a quantitative comparison of various techniques on the GSO validation set, focusing on chamfer distance, CD, and F-score, FS. The data reveals that TripoSR achieves the lowest CD, indicating superior reconstruction accuracy. Additionally, TripoSR attains the highest F-score at 0.5, demonstrating its effectiveness in capturing object details and overall shape fidelity. Table 3 presents a quantitative comparison of various techniques on the OmniObject 3D validation set, focusing on chamfer distance, CD, and F-score, FS. The data reveals that TripoSR significantly outperforms other methods, achieving the highest state-of-the-art performance in both CD and FS metrics. This table underscores TripoSR's superior performance in 3D reconstruction tasks using feed-forward techniques. Figure 2 illustrates the performance of TripoSR in comparison to state-of-the-art, SOTA, methods for 3D reconstruction, focusing on inference time and F-score. The plot shows that TripoSR achieves the fastest inference time, approximately 0.5 seconds on an NVIDIA A100 GPU, while also maintaining the highest F-score with a threshold of 0.1, averaged over the GSO and OmniObject 3D datasets. This demonstrates TripoSR's superior performance in both speed and accuracy for 3D reconstruction tasks. In this section, the authors quantitatively and qualitatively compare TripoSR to previous state-of-the-art methods using two different datasets with 3D reconstruction metrics. They curate two public datasets, GSO and OmniObject 3D, selecting around 300 objects from each to ensure a diverse and representative collection. For 3D shape metrics, they use marching cubes to extract isosurfaces and sample 10,000 points to calculate chamfer distance and F-score. A brute force search approach is used to align predictions with ground truth shapes. Qualitative results show that TripoSR achieves significantly higher quality and better details in reconstructed 3D shapes and textures compared to previous methods, capturing better overall 3D structure and intricate details. Figure 3 presents qualitative results comparing TripoSR's output meshes with other state-of-the-art SOTA methods on the GSO and OmniObject 3D datasets. The first 4 columns of the figure are from GSO, while the last 2 are from OmniObject 3D. The figure demonstrates that TripoSR's reconstructed 3D shapes and textures achieve significantly higher quality and better details compared to previous SOTA methods. This highlights TripoSR's superior performance in capturing intricate details and overall 3D structure, making it a standout in the field of 3D reconstruction. In this report, the authors introduced TripoSR, an open-source feed-forward 3D reconstruction model. The core of TripoSR is a transformer-based architecture developed upon the LRM network, with substantial technical improvements. Evaluated on 2 public benchmarks, the model demonstrates state-of-the-art reconstruction performance with high computational efficiency. The authors hope TripoSR will empower researchers and developers in advancing 3D generative AI models. The authors extend their gratitude to the Tripo AI team, including Yangguang and Zexiang for their critical roles in coding and experimentation, and to Stability AI for their support. Individual acknowledgements also go to Ping Huang, Huang, and Sienna Huang for their contributions. Thank you for watching.